$42.3 billion. I mean, just let that number sink in for a second. That is Gartner's staggering projection for global AI infrastructure spending in 2026. It's a massive, massive number, nearly doubling from the previous year. And what it really tells us is that the initial hype cycle of AI, yeah, that's over. The era of massive production-scale deployment has officially begun. Welcome to this explainer. Today, we're unpacking a tectonic shift happening right now, the shift toward AI inference. We're going to look at the high-stakes industry battle over where these billions and billions of dollars are actually flowing. Because we are fundamentally moving from a world focused entirely on teaching AI models to a world that is utterly obsessed with running them efficiently. So here's our roadmap for today. We're going to cover the AI spending boom, the pivot to inference, the catalyst of Agentic AI, the custom silicon war, the cost per token battle, and finally how AI is starting to write its own code. Let's just dive right in. All right, Section 1, the AI spending boom. We are talking about flooding the zone with capital. Let's start with the sheer scale of the capital expenditure happening right now. Gartner's data shows AI-optimized infrastructure as a service spending literally skyrocketing by 96.4% to reach that $42.3 billion mark this year alone. And it doesn't stop there. It's projected to hit over $66 billion by 2027. But consider the total hyperscaler capital expenditure. We're expecting it to reach between $660 and $690 billion in 2026. To put that into perspective for you, that single-year spend is more than the total GDP of many countries. And an estimated 75% of that massive CapEx is directed entirely at AI-specific infrastructure. We are genuinely witnessing one of the largest civilization-level technological build-outs in human history. Moving on to Section 2, this is where things get really interesting. Inference overtakes model training. Welcome to the 2026 inflection point. We are witnessing a massive pivot this year. Think about it. For the last few years, the big tech story was all about training, right? Just building those massive foundation models. But as Gartner reports, 2026 is the year spending on inference workloads at $23.3 billion definitively overtakes training at $19 billion. That is a 55 to 45% split. It essentially means businesses are finally pouring more resources into actually operating the technology at scale rather than just teaching it. And the economics here present a stark contrast. AI training is this heavy, one-time cost. You need highly flexible architectures to teach the model from the ground up. But AI inference? That's about using the model continuously. It demands real-time execution and is defined by extreme cost sensitivity. Training happens once. Inference happens billions of times a day. And as inference starts taking over 2/3 of all AI compute cycles, the hardware requirements have to fundamentally change. So why is this happening now? That brings us to Section 3, the rise of Agentic AI. This is the real catalyst for all this compute. We are moving past the simple prompt and response interaction. Agentic AI runs continuous, multi-step workflows completely in the background. Think about asking an AI to, say, plan a week-long trip to Italy. The system has to coordinate a whole sequence of decisions, checking flights, comparing prices, selecting hotels, booking them. This creates sustained concurrent workloads. It fundamentally shifts the system load and power requirements because the AI is constantly talking to itself, generating thousands of invisible tokens of internal reasoning before it ever gives you a final answer. Basically, the AI is doing a ton of stressful overthinking, so you don't have to. Because of that continuous demand, we arrive at Section 4, the custom silicon war. It's time to challenge the monopoly. Check this out. Custom application-specific integrated circuits, or ASICs, are growing at a staggering 44.6% compound annual growth rate through 2033. Meanwhile, general-purpose GPUs, the market NVIDIA currently dominates, are growing at just 16.1%. While NVIDIA's flexible GPUs are absolutely perfect for training, hyperscalers are actively shedding that Swiss Army knife flexibility. Why? Because inference requires highly specialized single-purpose efficiency. They just can't afford to pay a premium for general-purpose flexibility when they're running specific models billions of times a day. For hyperscalers, owning the custom silicon literally means owning the economics. And the biggest tech giants are now mounting a coordinated assault, fabricating their own ASICs. You've got Microsoft with the Maya 200, Google has the TPU V7 Ironwood, Amazon's got Trainium 3, and Meta has MTIA. They're buying up all the 3-nanometer capacity that TSMC can possibly produce, which is reportedly running at 100% capacity right now.
Because of this massive aggressive push for internal silicon, analysts actually project NVIDIA's grip on the inference market could plummet from over 90% today down to just 20 to 30% by 2028.
Which leads us perfectly into Section 5, the cost per token battleground. It all comes down to architecture and economics. Enter the concept of FP4, or 4-bit floating point precision. It's effectively pixelated math. Microsoft's Maya 2000 chip leans heavily into this, achieving an incredible 10,200 teraflops of FP4 performance. What Microsoft discovered is that during inference, you just don't need high-definition 8-bit precision for every single calculation. By compressing the data, you can process it incredibly fast without making the model's final reasoning any less accurate. In this world, simpler math equals blistering speed.
But look, speed is totally useless if you're starved for data. General-purpose GPUs often use hardware-managed caches. It's kind of like a librarian trying to guess which book you'll need next. It's a black box, and when the chip guess is wrong, you get latency. Microsoft took a radically different approach with the Maya 200, using a glass box architecture. It has 216 gigabytes of memory, and the compiler software has to explicitly tell the chip exactly where to put every piece of data. No guessing whatsoever. Removing the guesswork completely eliminates latency. And that is exactly what makes real-time, voice-to-voice AI conversations on your phone feel natural and instantaneous, rather than laggy and robotic.
So, why go through all this trouble to redesign chips from the ground up? The economics are just undeniable. Just look at Midjourney. They've reduced their monthly compute costs from $2.1 million to just $700,000, simply by migrating inference workloads from general-purpose GPUs over to custom Google TPUs. That is a massive 65% reduction. When you extrapolate that kind of cost reduction across billions of daily queries for a major cloud provider, you immediately see why they're pouring billions into custom silicon. It's the absolute crucial step required to make advanced AI assistants cheap enough for all of us to use every single day. And that brings us to our final part, Section 6. This is where things get a little sci-fi. AI actually writing its own code. We are now seeing a pretty wild twist in the industry. First, you have software like Triton, which abstracts the complex hardware so developers don't have to write custom code for every single new chip that comes out. But then you have Triton Forge. We are literally entering an era where AI agents are actually writing and optimizing their own hardware drivers. By letting AI analyze and tweak the code that runs the chips, developers are seeing an average speedup of 1.76 times, with some workflows running up to 5 times faster. The AI is optimizing the code that runs the AI. Which leaves us with this final thought. If AI is writing the software to make the custom hardware run faster, which in turn makes the AI smarter, which allows it to optimize the hardware even better, where does the road of self-optimizing AI actually end? As the shift toward AI inference takes over and these agentic workflows scale globally, this recursive loop of efficiency might just be the most powerful force shaping the future of our digital infrastructure. Thank you for joining me for this explainer. As AI begins building the very infrastructure it runs on, well, we are in for a wild ride.